Hello everybody, welcome to a new video. Today we're going to solve the word search problem on LeetCode. As an input we will have a grid of characters called board and a string word. So in this board we need to find the word in this board. For example, here we have the word ABCCED. This word exists on the board following this path. Second example, we need to find the word SEEE. This word exists on the board following this specific path. But if we try for this example ABCB, let's try. Here we have this EA, okay, good, B, okay, C, okay, but we don't have any B's after that. Well, actually there is this B, but we cannot reuse a character that has been already taken into the path, okay? So for this example, we don't have any, the word doesn't exist, so we return false. For these two examples, we return true because we found our words. Now, how are we going to solve this problem? Well, it's basically, searching on a graph. Basically, we will start from here and then we will try to, find, searching through the other nodes. This is our graph, okay? And we're going to try to search through the other nodes and see if we can find our word. Well, let us write the code so that it's easier to understand. So basically, each element here could be a start for our word, okay? So the start of the search. That's why what we're going to do first is we're going to have two nested loops. Okay, board length e++ and for int g less than board 0 length and g++. And then we will need our function that will build later on. We need to search while taking as our starting point this I and g, and if it's true we can return true. And if it's not true, we return false, okay? So we're going to take each element of the board as a starting point of our search. If we start from here and we don't find our word, we're going to the next element. Again, we're going to start from here and try to search. If we don't find anything from this point, we need to go here until we find, we find our word from a specific starting point, okay? And also, we will need to pass through the board. We will also to pass through the word. Okay. We will also need another variable, the initials at 0. I will explain what is it about. Okay, so private Boolean search. At first, we have our board, and we have then our word. Then we have our index. Then we have our I and G. Okay. So this index is going to point to a specific, element, a specific character in the word. It's going to start from 0. And obviously, if we managed to make this index superior or equal to the word length, that means that we've checked all the word's characters, and that means that we need to return true. That means that we found our word in the board. So if the index is superior or equal to the word length, that means that we found our word. And as you can see, as you will see later on, this index will be incremented each time we see that we found the corresponding character, okay? Anyways, and then we have I and G, so we need to make sure that I and G are not out of bounds. So if I is less than 0, or G is less than 0, or I is superior than board or equal to board length, or G is superior to board length, but this one 0, we need to return false. And also if the word I and G is different from the word char at index, the current index, we need to return false. Well, there is no need to continue our search because on the first, the starting point is already different from the char at index. Okay, cool. So we can just merge these two conditions and add this here. Oops. Okay, then what we need to do is now we need to start our search. We need to search, the other nodes. So we need to either to go here or to go here or to go here or to go here. In this case, it's out of bounds. So if I was here, I need to go either here, 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 here. So I need to recursively search here, search here, search here, and search here. Okay, so that's what I'm going to do. So I'm going to search. Well, I'm gonna put them in variables. So boolean top, I need to search at the top, the bottom, left, and right. And here board word, the index. Now the index is incremented because now I need to check, like for example, if I've seen that A exists in my path, now I need to check the next element, and then I need to make sure it exists somewhere. That's why I need to increment my index. Okay, I now because I need to check the top, that means that I should be I minus 1. I need to decrement the I, and G stays the same column. For the bottom board word, this time the index plus 1, but I, it should be incremented because the bottom I plus 1 should be here, and we keep the same G. Okay, and here again board word index plus 1, and it's left, that means that G minus 1, and board word index plus 1 I, because this time it's right, so G plus 1, and we need to return. So our word, we could either find it at the top by following the top path, okay, or the bottom path, or the left or the right. So basically the result of this search is the OR combination of all these variables. Okay, but actually we will have a problem, because imagine we are here at this point of our search, and then I need to find E. Okay, so basically what will happen is I'm going to look at the top, I'm going to look at the left, at the right, at the bottom. But the problem is that this element already exists in my path, so I should not, take it into consideration. So basically the trick here to do is we need to mark every element that we've traversed. Okay, so I'm going to use yes in our case. That means that this time we will be here in this element. These previous elements in our path would be equal to yes. But we must not keep it like this, because if we keep it like this and we try to move to another starting point, these elements would be, not the same, and it will give us wrong answers. That's why we need, after we finished our, search, we need to bring them back to their initial state. So after we finish our search, we're going to bring it back to their initial state, char at index. Okay, so I think we've got everything here. We ran the code. Okay, we've made a mistake. So array index out of bounds, index 4. Okay. So what we have here, so ig, we search the word from 0, the index ig, return true. Okay, I must not be negative, G must not be negative, E must not be superior to the board dot length, and okay, or equal. G superior equal, okay? Run the code. It works, submit the code. It works! Great, so this is it. Thank you for watching. See you in the next video. Bye.